Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So till now, I was teaching the 6th chapter of 9th standard mathematics that was on lines and angles. So now we will move on to the next chapter, that is 7th chapter in 9th mathematics, that is on triangles. So now you have already know what do you mean by triangles. In your 8th standard, 7th standard and all, you have learnt about triangles. So three straight lines come together to form a closed figure. So for example, if there is one straight line like this, and if there is one more straight line like this, and if there is one more straight line like this, so here you can clearly see there is the formation of a triangle. So this particular figure which I am getting here can be known as triangle, because if you split the word triangle, tri means three, angle means, we already know angle is something which is formed in between two straight lines when two straight lines intersect with each other. So here, when these two straight lines are intersecting, here one angle is forming. When these two lines are intersecting with each other, here one angle are meeting. Here one angle is getting created. When these two straight lines meet together, here also one angle is getting created. So that means here clearly you can see three interior angles are formed when these three straight lines form a triangle. So that's why this kind of image is known as triangle. That is three angles, three interior angles formed by this closed figure, where this closed figure is formed by three straight lines. So always you should remember that in triangles you have three sides. So in triangle you have three sides, in triangle you have three angles, and in the triangle you have three vertices. So all these things you have already learnt in your previous classes. So I am just brushing up all these things. So here you can see this is one side, this is one side, and this is one side. So three sides are there, and this is one angle, this is one angle, this is one angle. Three angles are there. This is one vertex, this is one vertex, and this is one vertex. So three vertices are there. So this forms a particular triangle. So here, if you have four sides, that is four straight lines enclosing, then it is known as a quadrilateral. So if five sides are there for a particular figure, for a closed figure, then that is known as pentagon. Similarly, hexagon, heptagon, octagon, all those things will be there. And all these things I have explained in 8th standard mathematics. You can refer those videos. So now here we have three sides. So three sides is there in this particular closed figure. So three straight lines are forming this particular closed figure with three sides, three angles, and three vertices. So now we will look into one particular concept here, which is known as congruence. So what do you mean by congruence? Whatever figure if you are taking, so if they are exactly overlapping, the size of those two figures, if they are exactly overlapping on each other, then those two figures are known as congruent figures. Now if you take two bangles of same size, so if you take two bangles of same size, so basically you're considering two circles of same size, because the bangles what you wear, so those bangles are in the shape of circle. So two circles are there. So two bangles are there of same size. Don't worry about the color. We are not dealing with the color of that particular bangle. We are only concerned about the shape of a particular object. So two bangles are in circular shape, and these two bangles have same size. That means these two circles have same radius. So because these two circles have same radius, when you keep one bangle on another bangle, so let's say this second bangle, if you keep on first bangle, then you can clearly see the second bangle will exactly coincide with the first bangle. So then if that is happening, then these two circles are congruent circles. So that means these two circles have same size and shape. So that's why these two circles are overlapping on each other. Now similarly, if you consider two A4 sheets, So now if you consider two A4 sheets, so if you keep one A4 sheet on another A4 sheet, then you can clearly see the second A4 sheet is exactly overlapping on the first A4 sheet. So that shows here these two A4 sheets are in rectangle shape and these two rectangles are overlapping on each other. So that means these two can be known as congruent rectangles. Similarly, if you are taking two triangles, where both the triangles, all sides are matching with each other and all angles are matching with each other, that is this side and this side, this side and this side, this side and this side. So all these three sides are matching with each other and all these three angles. So this angle and this angle, this angle and this angle. Similarly, this angle and this angle. So the corresponding angles of both the triangles and the corresponding sides of the both the triangles are equal to each other, means these kind of triangles can be known as congruent triangles. So based on this particular concept, we will be looking into different axioms and theorems, that is SAS axiom or ASA theorem. So all those things we will be learning in this particular chapter. So this entire chapter will be based on this congruence concept. So now in order to prove two triangles are congruent, you have one axiom. So now we are looking into the first axiom in this particular chapter, that is axiom 7.1. So in axiom 7.1, the name of this particular axiom is SAS congruence rule. So the name of this particular axiom is SAS congruence rule. So now in this particular axiom, if side angle side of two triangles, so whenever I use SAS axiom, then S represents side, A represents angle, again S represents side. So side, angle, side. So that means here continuously you have to consider side, then angle, then side. For example, if you have two triangles like this, so let's say two congruent triangles are there like this. So this particular side if you are considering, then next you have to consider this angle and this side. So that will be side, angle, side. So for example, here if you consider this particular side and if you consider this particular angle, and instead of considering this side, so instead of considering this particular side, if you are considering this side, then this is not SAS, because this becomes yes, yes, A. So always remember that you should go anti-clockwise. So when you go anti-clockwise like this, so whenever you go anti-clockwise like this in a triangle, then side, angle, side should be equal of both the triangles. Then you can say these two triangles are congruent with each other. So that means here, if I am considering ABC as one triangle, and if I am considering PQR as another triangle, here if AB and PQ are equal, BC and QR are equal, and if ABC and PQR are equal, then these two triangles are congruent triangles. So here AB is equal to PQ and angle ABC is equal to angle PQR. At last, BC is equal to QR. So in this format only it should be there. Or let's say if you are considering, if in the same two diagrams, I am writing these two triangles once again. So one is ABC, the other is PQR. So now let's say if you consider PR side and if you consider AC side, then you should consider this particular angle, because you should go anti-clockwise like this. So after this side you have this angle, after this angle you have this side. So that becomes yes, a, yes. So there is no ASS postulate or axiom is not there. Similarly, SSA postulate or axiom is also not there. Only SAS postulate is there or axiom is there, and ASA axiom or theorem is there. So only SAS and ASA is possible. ASS is not possible. SSA is not possible. So in order to not get confused with this, just go anti-clockwise in the triangle. So if you are considering this side, then consider this angle and this side. Or if you are considering in the same triangle, if you are considering this side, then consider this angle and this side. Or if you are considering the same triangle and if you are considering this side, then if you are considering this side, then consider this angle and this side. So for all these triangles, SAS rule you are following. So using this axiom, you can prove ASA also. So now based on this axiom 7.1, we have one example in this particular chapter. So now we will look into the first example, that is example 1. So in this particular example 1, we have one figure. So here there is a particular figure like this. So just draw that figure. So basically two triangles are there like this. So here in these two triangles, this particular point is O, this point is C, B, and this point is A, and this point is D. Here, this particular angle is equal to this particular angle. This particular side is equal to this particular side, and this side is equal to this side. Now you have to prove that OCB and OAD, these are the two triangles. These two triangles are congruent or not. Now, in order to prove this particular two triangles are congruent or not, we will alter this diagram. So now, just write this particular triangle. Just write this particular triangle. So I am just writing the below triangle one more time like this. So the below triangle, it looks something like this. So this point is O, this point is A, this point is D. Similarly, this OCB triangle, I'll rotate that and I'll place it on CB. So in such a way that when you rotate this particular triangle, this also looks similar to AOD triangle. So when I rotate this, B will come to this particular end and C will go to this end and O will be coming here. Here CO and OD are equal to each other. So here CO and OD are equal to each other. Here AO and OB are equal to each other. So here AO and OB are equal to each other. And here AOD and COB are equal to each other. So AOD and BOC. So AOD and BOC are equal to each other. So AOD and BOC are equal. So now you can see, if you go anti-clockwise, here you can clearly see yes, A, yes axiom you can apply on these two triangles. So that means here OD is equal to OC and AOD is equal to BOC, and here OA is equal to OB. So according to SAS axiom, here triangle AOD is congruent to triangle BOC. So here triangle AOD is congruent to triangle BOC. So this is the symbol which is used to represent congruence. So if I am writing this symbol between two figures, means those two figures are congruent with each other. So here triangle AOD is congruent with triangle BOC. So that is what we need to prove in this particular example, and we have proved that. In the same example one, you have second part also. Here you have to prove AD is parallel to BC. So now I'll write the diagram one more time. So we had diagram something like this. So we had diagram something like this. Here this is CB, this is O, this is A. So here I have written this particular figure one more time. Here we have to prove AD is parallel to BC. Now we will consider angle CBO and we will consider angle OAD. In this figure you can see OAD is this particular angle and OBC is this particular angle. Here also OBC is this particular angle, AOD is this particular, OAD is this particular angle. So here this angle and this angle should be equal to each other, because here in the first case we had proved that this particular triangle is congruent with this particular triangle. So that means here, since AOD triangle, so triangle AOD is congruent with the triangle BOC, here this particular CBO angle will be equal to OAD angle. So since CBO is equal to OAD angle, these two acts as alternating angles when you draw a transverse line for those two parallel lines. So that means here CB and AD, if they are parallel lines, then this AB acts as the traversing line. And these two angles acts as the alternating angles if CB is parallel to AD. Now we have proved alternating angles, these two angles are equal. So that means alternating angles are becoming equal. So therefore here CB is parallel to AD. And in the question also they have asked AD parallel to BC. So that we have proved here. Now we will look into the next example in this particular chapter, that is example 2. So in example 2 we have one particular diagram. So this point is A and this point is B and this point is P. So in question they are saying that there is a straight line named L which bisects this particular AB straight line. So that means this particular AB straight line, what is there here. So this line is perpendicularly bisected by this particular L and it is also passing through the point P. So that means this L is passing through P and it is bisecting AB and it is perpendicularly bisecting AB. So that means this angle and this angle will be 90 degree. So this angle is 90 degree and this angle will also be 90 degree because this line is a perpendicular bisector of AB straight line. So AB is one line, L is one line. So here L is perpendicularly bisecting AB. So that means it is exactly dividing AB into two halves. So whenever I use the word bisector, bisector means it exactly divides a particular object into two halves. So here AB is a straight line. So this perpendicular bisector means it is exactly dividing AB into half in such a way that angle created between this line L and AB will be equal to 90 degree. So if this side, if it is 90 degree, this side also it will be 90 degree because here they have named this point as C. So here since AB is a straight line, so if you are considering ACB angle, then the total angle will be 180 degree. So that means here if this is 90 degree, then this will also be 90 degree because this is a perpendicular bisector. Now you have to prove. So here what we need to prove is that, so I'll just write to prove. So here you need to prove AP is equal to BP. So I have to prove AP is equal to BP. Now here clearly you can see two different triangles are formed by this particular bisector. So since here we are getting two triangles, we'll try to prove that these two triangles are congruent to each other so that we'll get AP BP equal to each other. Now here you can see PC is the common line for both of this triangle. So I'll just write this two triangles one more time in the new slide. So here just draw this figure one more time. PC is one particular line which is common for both this ACP and PCB triangle. So now we will consider two triangles. So consider triangle ACP and triangle BCP. Here PC is common line. So PC is common side. We'll call common side for both the triangles. So here PC is common side for both triangles. Therefore, PC is equal to PC. Similarly, this particular angle is also 90 degree and this particular angle is also 90 degree. So that means here, since L is perpendicular bisector, so since L is perpendicular bisector of AB, here ACP angle will be equal to PCB angle, which is equal to 90 degree. So that means we are considering this side and we are considering this angle and we are considering this side. So here you can see we are going anti-clockwise like this. So that means this side, this angle and this side we are considering. So that means SAS congruence rule we are applying here in order to prove these two triangles are congruent with each other. So now we have got PC as common line and we have got two angles equal to each other. Now we will prove AC is equal to CB. Here, since L is bisector, so since L is perpendicular bisector of AB, so since L is perpendicular bisector of AB, here AC should be equal to CB. So that means here we are getting AC is equal to CB and we are also getting ACP is equal to BCP. We'll call this as equation 2. And here PC is equal to PC. So here you can see this particular side we are considering, this angle we are considering, and this particular side we are considering. So in anti-clockwise we are considering SAS. So that means here SAS congruence rule can be applied. So according to SAS congruence rule, here triangle ACP is congruent to triangle BCP. Since these two triangles are congruent with each other, then all sides of the triangles of these two triangles and all angles of these two triangles should be equal to each other. So that means corresponding sides and corresponding angles of these two triangles should be equal to each other. So that means here AP will be equal to BP. So because triangle ACP is congruent with triangle BCP, therefore AP is equal to BP. So we have proved that this particular point P is equidistant from point A and it is equidistant from point B because AP is equal to BP. So at last you can write the sentence that therefore since AP is equal to BP, P is at equidistance from point A and point B. So this is all there in this particular video. You have learnt about SAS axiom and also you have solved two examples which were there in this particular chapter. So in my next videos, I'll be teaching about ASA rule, SSS rule and also RHS rule. Along with that, I'll also be explaining the exercise questions. Until then, if you want to learn more physics, chemistry and mathematics starting from 8th standard to 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.